Hi guys, so today we are going to discuss about the multi-container related topic. Keep in mind this is a two-part video, and today we are going to discuss about the init container type. So first off, the init container is useful when we need to do some specific task before running our actual application. So as an example, some processes which is used to connect to a database. So if the database is not active or started, the process would be crashed. So in order to avoid those kind of scenarios, we can use the init container concept to just check whether the database is up and running. If only it's working, then we can run our actual application process in the main container. So here the question states that create a YAML manifest for pod named complex pod. The main application container name app should use the image nginx this version and expose the container port to 80. Modify the YAML manifest so that pod defines an init container named setup that uses the image busybox this version, and the init container runs the command wget -o-google.com. So then we will create the pod from the YAML manifest, then download the logs of the init container. You should see the output of wget command. Open an interactive shell to main application container and run the ls command. Exit out of the container, and finally we can force delete the pod. So to get things started, I will run kubectl run. The pod name is complex pod, and the image should be nginx. Then we can expose the port 80, and then we can redirect the definition into a YAML file by adding dry run equals to client and dash output is a YAML one. So here's the manifest we created. Here the container name should be changed into app. Then we need to add a init container into this pod. To do this one, we will go to the documentation and search for init containers. Here in the first search result, if we scroll a little bit, we get a block of init container definition. So we can copy this one and let's paste it under here. So our init container name should be changed to setup, and the image should be busybox 1361. So we have to change this one, and the command we need to run in the init container is this one. So we only need to replace this part. So this is the actual definition we need to create the mentioned pod. So then we can create the pod from the YAML file. To do that one, we can run kubectl create -f pod.yaml. The important thing we can note of is initially the complex pod is running the init container. Then after some time it will change to running, and now it's running the app container. So it's something you have to note of. The init container and the actual containers execution order is first init container, and then only after that the main container starts its execution. Also, one more thing to note of is that we can add multiple init containers, and all these init containers will run in a sequential order. So then we can download the logs of init container by running kubectl logs. The pod name is complex pod, and our container is setup. So this is the log we get when we run the kubectl logs complex pod -c setup. So here, if we scroll up, then we can see that command is executed successfully. Then we need to open an interactive shell to the main application container and run the ls command. To do that one, we can run kubectl exec -it, then the pod name is complex pod, and then we need to define the container. We can use /container or -c, and the container name is app. Then /bin sh. Okay, we are connected to the pod, and then we can run ls command. So here's the output of that one. Then we can exit out of the container by typing exit. Okay, now we exited the container, and if we need to delete the pod in a forceful manner, we can use kubectl delete complex pod, and we need to add false flag, and then we can define the grace period to 0 as well. We need to add the resource type as well. So here we were able to delete the complex pod forcefully. The reason for setting the grace period to 0 is usually Kubernetes gives the pod a grace period of 30 seconds, and only after that it sends a signal to the container waiting for the app to shut down cleanly. But sending the grace period set to 0 bypasses this wait and remove the pod from the API server immediately. So in the next video we will discuss about the sidecar pattern, the adapter pattern, and the ambassador pattern. So thank you. We will see you next time.